Welcome to Investigation 3.2, Counting Handshakes. This is another quadratic function. So for our focus question, we have if each team has n members, so any number of members, how many handshakes could potentially occur? So we're going to go through a couple parts of this problem. We're going to look specifically at case number 1. Case number 1 suggests we have two teams that have the same number of players. Each player on one team shakes hands with each other player with each player on the other team. Number 1 states how many handshakes will take place between two 5-player teams, and then how many handshakes will take place between two 10-player teams. So when I see a problem like this, my very first instinct is to draw a picture. Drawing pictures can be a really healthy tool, and that's how I can model with mathematics. So going back to our awesome math practice standards, so I can model with mathematics. So here's my picture that I'm going to make. Here, there's one team, 5-player team, and here's my other team, a 5-player team. From there, I only need to figure out how many handshakes are going to occur. I have 1 there, 2, 3, 4, 5. So this player has shaken hands with 5 people. I need to do the same thing with the next one. 1, 2, 3, 4, 5. Same thing. Again and again and again and again. And what I'm noticing is each player shakes hands with every other player 5 times. So if we have 5 total players on one team and 5 total players on the other team, I'm seeing that we have a total of 25 handshakes. So relating that back to the number of players we have, I have 5 players times 5 other players, and I get 25 total handshakes. 25 handshakes. Between 10-player teams, I could see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's one team, and here's my other team. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Big teams. I'm going to go through this same thing, a little bit of math magic for you so you don't have to watch it all, and we'll go from there. So I can see again, I have 10 players, 10 handshakes went to every single one. So I could say I have 10 players, 10 total other players, and we get 100 total handshakes. So we need to now write an equation for this total number of handshakes looking at this situation. If we had H handshakes, how many between two whatever number player teams, n player teams, what is occurring? So if I look at my equations that I'm already creating for these two situations, the number of handshakes is determined by the number of players times the number of other players that they're playing against. So we have 10 times 10 equals 100 handshakes, or 5 times 5, which is equal to 25 handshakes, but it's essentially n squared. So the number of players that are on the same, essentially one team with the same number of players as the other team, you'll have an equal number of handshakes between the two of them, and so therefore the handshakes, or the number of players, is just squared to get the number of handshakes that occur. Case number 3. So we're looking at high fives this time. Each member of a team gives a high five to each teammate. So we're looking specifically within a team. Instead of looking at two teams working together, we're now just looking specifically at one team. How many high fives will take place among a team with 4 members? How about among a team with 8 members? So if we're looking just at a 4-person team, here's my 4-person team. We have essentially one teammate is going to high five 3 teammates. This teammate on the right-hand side, he's going to be, well, he's already high-fived the first teammate, so he gets to high-five the one opposite him and the one next to him, so he's now high-fiving 2 people. The person at the bottom, they've already high-fived the person on the right and the person above. They just need to high-five the person next to him, and he's got 1. Now this person right at the end, he's high-fived everybody, so he doesn't have to high-five anybody. So we have 6 high fives. Pretty sweet. If we look at an 8-person team, we now need to figure this one out. So we have 1, 2, 3, 4, 5, 6, 7, 8. 8-person team. Let's see how many high fives we have. We have 1, 2, 3, 4, 5, 6, 7 by this guy. By the next person, he's already high-fived the person right next to him, so he's going to be high-fiving this guy, this guy, this guy, and already over here, so we have now 6 high fives. The next person over, he's high-fived 2 people already, which is pretty sweet, so he only needs to high-five 1, 2, 3, 4, 5 people, and so on. So a little math magic for you. So now what I see is we have an 8-person team, and what I'm seeing is we have 7 high fives, 6, 5, 4, 3, 2, and 1 high five. So 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 plus 0. Add all those up together and we get, I'm going to show you a little bit of ways to play around with this. We have 7 plus 1, we get 8. 6 plus 2, we get 8. 5 plus 3, we get 8. And we have 4 left over. So 8 plus 8 plus 8, 8 times 3 equals 32 plus another 4, and we get, 8 times 3 is not 32, sorry. 8 times 3, which is 24, plus another 4, and we get 28 high fives. So our last step we need to take is actually looking at what is occurring for a particular graph for this, or like a particular equation. What I'm noticing is we have, essentially, if we have a certain number of players, we have a certain number of high fives. So for 1 player, we'd have 0 high fives. For 2 players, we'd have 1 high five. For 3 players, we'd have 3 high fives. For 4 players, it went up to 6 high fives. For 5 players, 6, 7, 8, I don't know 5 through 6, but for 8 we had 28. So if anything, we need to now figure out what sort of pattern we have going on here, so that way we can maybe create an equation. I see a plus 1, a plus 2, a plus 3. So I'm looking at the pattern of change. So if I were to guess, I'm guessing that it'd continue with a plus 4. And if that were the case, we'd have 10 high fives for 5 people, for a 5-person team. We'd then have a plus 5, a plus 6, and then the last one would be that plus 7 to get us to 28. So that would mean our 6-person team would have 15 total high fives, a 7-person team would have 21, and our 8-person team would have 28. So that pattern fits with our data. From there, we need to think about how we can make this data work for what we need to have happen. So what I noticed with our data, I'm just going to look at our 8-person high five. I was saying that we have 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 plus 0, essentially. If I were to ignore this plus 0, because it really doesn't matter, if I were to look at this, I have 8 that I can add up, I have another 8 that I can add up, and another 8 that I can add up, and then I have 4 left over. So what I'm seeing as of right now is I'm using, of the numbers, I'm adding them to make 8s occur, and that 8, if I remember right, is the number of players that I had. So I need to create an equation that relates back to that number 8, and we know this is quadratic because everything we've been doing has been quadratic thus far. If I were to take 8 and square it, I get 64. Now, how does that relate to 28? 64, if I were to divide that by 2, I get 32. And 32 in comparison to that 28 is 4 less. Ooh, interesting. So 8 times 8 times 8 is 24, and we have 4 left over. What if I had that 8 squared? Well, in all reality, this looks very similar to our equation that we created for triangular numbers. We have 8 squared. We could subtract 8 and divide this entire baby by 2. 8 squared is 64. Subtracting 8 from that would get us 56, and 56 divided by 2 gets me 28, hence my number that I want. So a generalized equation for this particular situation would be n squared minus n divided by 2. Vaguely like triangular or exactly like numbers. Kind of fun. Actually, I think it's more vaguely like. Either way, here is my equation that represents the number of I should write not handshakes, but I'll write high fives for this, for any number of players. Play around with this investigation, go through case number 2, and then we're going to be starting into 3.3 if you have not already done so, and you're going to be using the equations that you create from investigation 3.2 in 3.3 to identify some graphs. I hope this helps. I hope you enjoy the rest of your evening, and I will talk to you later.